in this scenario? The top one. Equal variances assume because my Levine's test tells me I can assume I have equal variances. So I look on here. My t is negative 14.638. The degrees of freedom is 6,121, which is how we would calculate it. 2932. So the n of group 1 minus 1 plus 3189, the n of group 2 minus 1. We just add up those 2 degrees of freedom, and that gives us this value right here. The SIG, my observed p-value says 0.000. So what does that mean? It's very, very significant. The probability of observing a t of negative 14.638 is so small that it's not even registering on the SPSS output. It's less than 0.001. It's so far out in the tail ends of the distribution that we can't even, that SPSS isn't even telling us the precise probability. So this is a highly significant difference, right? There is a significant difference between males and females in their reports of how involved they are with their mothers. And then SPSS also calculates the mean difference, which is just your mean for group 1 minus the mean for group 2. You could also calculate that on your own just by going up here into your descriptive data. It calculates the standard error of the mean difference, which is the denominator of your t. So these are, you can double check, take this value divided by this value, and it would give you your t. So it's calculating all the parts of the analysis for you. And then the last thing it provides is this confidence interval for the mean difference, which we have not talked about. This is chapter 12. So for now, you're not going to really attend to these because we haven't talked about these in class yet. All right, let's come back to effect size after we finish looking at the other one. Does anybody have any questions about this output that we just looked at?
There's formula reason SS1 for the best sum of squares.
Yeah, so this is our formula for the pooled variance. And we'll do this, we actually are going to do a hand calculated example too. So you take your, this is what you guys covered on Tuesday. You take the sum of squares for group 1 plus group 2, and then you divide it by the degrees of freedom for group 1 plus group 2, and that gives you your pooled variance, which you then use to plug into this formula. And we'll go through another example of that too. So. Okay, now before we move on to effect size, let's do this last one here. So this is, any other questions about?
How do we know which, if say male or female involvement, if there's a significant difference, how do we know if like female involvement is way lower or female involvement is way higher?
Good question. Yeah, actually I forgot to talk about that. You have to go back to your means to look at that. So this is a significant difference. It tells us that we have, that there is a significant difference between males and females. In order to know who has higher and who has lower, you got to go back to your means. So our mean said 3.5994 for males, 4.3132 for females. So females are higher. That's how you interpret it. Now, if you think about how you calculate the math here, what SPSS did was it took the mean, so that for this t, took the mean for females. Oh wait, no, it took the mean for males minus the mean for females divided by the estimated standard error. Now, is there a rational or logical reason why SPSS took the mean for males minus the mean for females, which ended up with a negative mean difference because the mean for males was smaller than the mean for females, which ended up then with a negative t. So is there any reason why we would do males minus females as opposed to females minus males?
I'm just taking a stab in the dark. When you put the dialog box up with the comparing, group 1 versus group 2, should you have compared it from group 2 to 1? And then would have it switched it or no?
It won't, because SPSS just takes 1 minus 2. So if you put 2 and then 1, it'll still take 1 minus 2.
Oh.
So what that means is that this is arbitrary. It's totally arbitrary which one you label group 1 and which one you label group 2. I could just as easily, because I'm a feminist, labeled females are 1 and males are 2. In which case, SPSS would have taken the mean for females minus the mean for males, and the t, the mean difference would have been positive, and the t would have been positive. So, but if you look at your distribution, your t distribution, regardless of whether we say males are group 1 or females are group 1, the magnitude of the difference, the size of the difference between your groups is the same. The only thing that this affects is whether your mean or your t is on the top end of the distribution or the bottom end of the distribution. The size of the t is going to be exactly the same, right? Because this mean difference is just the size of the difference between your groups. If you take males minus females, you end up with a negative number. If you take females minus males, you end up with a positive number, but the magnitude of the difference is exactly the same. So if I had labeled males as 2 and females as 1, my t would be positive 14.638, and I'd be way up here on this tail end of the distribution, but my decision would still be to reject the null, right? I would still say there's a significant difference between the groups. Then I would go back to my means, and I would say females are larger than males, so females are reporting more involvement than males are. So the take-home message is, when you're doing your homework assignments or whatever, you can label these things however you want. It's an arbitrary decision. Your t, if you label it one way, may end up as a positive value on this end of the distribution. If you label it the other way, your t will end up on the negative end of the distribution. So the sign of your t will depend on how you arbitrarily choose to label your categories, but the size of the t, whether it's in the critical region or not, is the key. I mean, that's how you interpret. Then when you go to your step 6 and you're trying to make sense of it, you have to return to the means and say, okay, who did better than who? Does that make sense?